So here is how you can do some simulations and actually run things on real quantum computers using Qiskit. So I'll start by looking at just real basics. So QC equals a quantum circuit 2, so I have 2 qubits and I draw it, and here it is. And those will both be 0 unless I tell it otherwise. I can then tell it, I can use various different features to display. So here I am telling it that I am creating a state vector that I want to be in state 1, and then I am drawing it, and so it's just showing that I can do that. And then I could change this to 0, and there we have that. So I can also display it on a block sphere, and so here I have a Bell state, and here is its depiction on the block sphere. And then here I just did the state 0, and then here's just plotting 0 and plotting 1. And now I am saying, asking it to draw the state of a circuit, but I didn't run it. I just set up the circuit. So when I draw the state, it'll be 0, 0. And then I put some gates in and put a Hadamard gate in. Did I rerun this? Nope, I didn't. So look, see, I knew something. See, I knew I hadn't rerun it because it didn't have the minus sign. Right? See, I did know something. So what I had done before was I had this without that line. Oh, but now it's redrawing the whole thing. Okay, so I come here, reset it, and redraw it. So now I have just the Hadamard gate, and then I draw it, and I get the plus sign, and then I added this in. But I need to reset it, because all it does, it adds the gate, but it doesn't. There we go. Okay, now when I draw it, I put the X in the wrong place. Oh, right. Let's see. There we go. Okay. So, 0. Okay, so it has them qubit 1 coming first. So, okay, so yeah, so qubit 1's coming first, and so it's 0, and then the second one is from the Hadamard gate, and then Right. If I did this, reset. There we go. Okay. And then now I can make a bell state by adding a controlled X gate, C0 gate. And then here, is this the one I was looking at when I just was pleased with myself a moment ago? I bet it was. So if I take that out, oh, because it's just drawing the state. It's not drawing the state. No, it is. Hold on. Well, I don't know. Okay, so I need to think about that one. All right. Okay, so those are the basics. Now that is just setting up the circuit and then getting the just a single run. But then you can also use sampler and the estimator, and you can get either a probability distribution or the expected values, and I'm really having a hard time figuring out how all of this works, but I was able to do it. And let me get that. Okay, so here we're going to use a simulator, so this is not the actual quantum computer, and we'll make a bell state. And we will measure it. It took me forever to find just this simple measure. And then we will plot it. Okay, because to measure it, we have to use this sampler and not the estimator, which is what their tutorials were all using. Okay, so first we are going to get the air simulator. Then we are going to create a quantum circuit with a Bell state, and then we're going to execute it with 1,000 shots, and then we get our results, and then we can plot it. Okay, so now what would happen if I change things up a bit? First I want to draw this circuit, make sure it looks like what I think it looks like. Now I call it QC. Oh, I called it Bell. Hadamard gate, C naught, measure. Okay, that looks right. Okay, so now look at what I do. I prepare the states ahead of time. So I initialize them. And then I get the distributions. And so that is the difference I get from initializing them. That's not right, is it? That's also not right. I somehow managed to delete all my code, so enough of that. I wasn't sure what I was doing anyway. Okay, and then now back to the official example here. I can tell you what it is doing. I can't tell you exactly why. So we start off same as with the other examples I had. So QC is a quantum circuit, has 2 quantum registers. If I wanted to put a classical register in there, I'd do 2 comma and then however many classical registers I wanted. Do I have an example? Yes. So here's an example of that. So here is a quantum circuit with 2 quantum registers and 2 classical registers. Okay, so I have that, and then I create my Bell state, and then I make these 6 observables, and these are the tensor products of the Pauli matrices, and you should get that 1 for Z, Z, and X, X if it's entangled. The sparse Pauli, I'm not entirely sure what that does. It's something more efficient. I don't know what that is really. And then I set this up to run on my quantum computer. And when I do that, it has to make this ISA circuit. When it makes the ISA circuit, it has to convert it to run on the hardware of that particular computer. And did you have something you wanted to say, Noah? And my cat's participating here. That was it? That was your only comment? And so it might change the phase of everything. It will rotate. That's the square root of x. I'm not sure what this one does, but that is supposed to be the same circuit, do the same things as a circuit that we had before, but converted to run on the hardware for the particular computer that we have chosen here. So that's the ISA circuit, and I think they call that transpiling. And then I collect my data, and that is done through this estimator, which gets the expected value. And here I tried, but I don't understand. But I know that I'm running it with 5,000 shots, and then I know I can go back and get that data, and I can get it, and I did this several times, and I can retrieve it, and then I can plot it, and this is what I get. And everything would be nice if these were 1. Well, if this top one was 1 and not 1.4, but I think it's possible. Is that real data, or did I do a simulator? That looks like real data. So maybe that's not so bad. What did I do here? I used a simulator or a fake back end, and I did not put a CNOT gate in. I just wanted to see what it would do. So I would expect, so qubit 0 has the Hadamard gate, so that makes a superposition. And so we would expect I don't know what we expect. And then I tried some other things. And then I also had so this hello world that I've been showing with those 6 observables is the one that they have on the web page, but it's not the one that he shows in the video. In the video he has a slightly different one. And this gets exactly what we would expect. And we get this, but this we're running not on a quantum computer, but on a simulator. So that does get exactly what we would expect with the 1 for ZZ and XX and 0 for the others, or close to 0. And then I extend it to a different state, and then here I just kind of, let's see, what did it say we were doing? So the steps that they say to do is that you build the circuit. So these are the steps. So you build the circuit, and then you optimize it, and then you execute it on the back end, and then you process it and plot it. And building the circuit includes transpiling it to get it to match the hardware that you're going to be running it on. And that's all I have to say about that.